Trigonometry, Chapter 11, Trigonometric Functions, Section 2, Angle Relationships in Similar Triangles, Video 6, More Similar Triangle Examples. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous videos, we discussed congruent triangles and similar triangles. We discussed sufficient criteria for each and worked a couple of similar triangle examples. In this video, we look at two more similar triangle examples. Example 1. A tree casts a 45-foot shadow. At the same time, a 6-foot man casts a 9-foot shadow. Find the height of the tree. Well, although not necessary, a picture would help. Later, pictures will be necessary. I sometimes say the trick to doing trigonometry is to draw a damn good picture. So this is not a good picture, but it'll suffice. We have a 6-foot man casting a 9-foot shadow, and notice I have the sun rays going from his head to the base of the shadow, and we have a tree casting a 45-foot shadow not drawn to scale. Now we assume the angles the sun rays, the dotted lines, make with the ground are congruent. This is why it says at the same time. We also assume both the person and the tree are perpendicular to the ground. In other words, make a right angle. So we're assuming two congruent angles. Since we have two pairs of congruent angles, we have similar triangles. That's one of the criteria for similar triangles. So we want to find the height. Let's label it H. And now we have some corresponding sides to set up as ratios in a proportion. We'll set up the ratio of shadow lengths to the ratio of heights. The shadow lengths are 9 and 45. The heights are 6 and H. Now we simply solve. Cross multiply to get 9H equals 270. 6 times 45 is 270. Divide both sides by 9, and we get the height of the tree is 30 feet. Pretty straightforward. Tree is 30 feet tall. Now, did you notice that there was a scaling factor from the person's shadow to the tree shadow, and that scaling factor was 5? The tree shadow was 5 times as long as the person's shadow. So we could have just said 6 times 5 is 30 and been done with it. That's not always that easy, but if you spot the scaling factor in similar triangles, you can take advantage of it. Example 2, find the value of x. I love problems like this. You really have to think and do a deep dive. Let's see what we have. We have a right triangle ABC, and we have a smaller right triangle ADE. One side on the larger triangle is 110, one side on the smaller triangle is 50, one side on the smaller triangle is x, and then we have this distance between D and B of 120. Notice this 120 is not a complete side on either triangle. So there's two issues with this problem. The first one's more obvious than the other. The first issue is the triangles overlapping. We have triangle ABC, the large one, and ADE, the small one. Sometimes it's helpful to draw these triangles separately. So let's copy the image. And now we're going to trim down the triangles. We'll trim down the left triangle to be ABC, the larger of the two triangles, and we'll trim down the one on the right to be triangle ADE, the smaller of the two triangles. Now, before setting up the proportion, which would be the ratio of bases to the ratio of heights, notice the length of segment AB is x plus 120 down here at the bottom. X and then 120 more. So it might help to replace that with x plus 120. It's not necessary, but if it helps, do it. Now we can set up the proportion. The ratio of the bases in yellow. On the left is x plus 120. On the right is just x. The ratio of the heights in blue. On the left is 110. On the right is 50. I should point out that the scaling factor here is not immediately clear, but it's 2.2. That wouldn't help us, though, because the bottom sides both have x's. Now, the second issue with this problem is that the proportion contains x twice. This will not change how we start solving it. It'll just change how we finish it, because we're still going to start by cross multiplying. So we'll do 50 times x plus 120 equals 110 times x. This diagonal product equal that diagonal product. And now we'll distribute the 50. 50 times x is 50x. Not sure what happened. Are we not sharing anymore? I'm not quite sure what just happened there, but let's continue. We have 50x plus 6,000 equals 110x. If you have x's on both sides, you have to fix that. So we're going to subtract 50x on both sides. And when we do that, we get 6,000 equals 60x. And when we divide both sides by 60, we get x equals 100. So be careful on tricky problems like this with overlapping triangles. Split them, carefully label the sides, and then proceed. Always be careful, observant, and deliberate. When you encounter a new or tricky situation, make a plan, carefully implement it. Now you try. Pause the video and try the following problems. Number 1, find the height of a building that casts a 50-foot shadow if, at the same time, a 6-foot tall person cast a 3-foot shadow. And number 2, find the value of C. Here we have two triangles, a larger one and a slightly smaller one. All right, this is your warning. If you haven't paused the video yet, solutions in 3, 2, 1.